guys, back again. Wanted to do this video here on old dry system that that we come out and do service and repairs on. I thought this one, picking out this particular dry valve to do a video on was kind of a good one, just because it's an old valve. So you guys are gonna probably come across this stuff, especially if you're in service work. So these are pretty interesting stuff to look at, and I'm just going to go into a little bit of details on how it works and what to look out for. Okay, I'm going to turn the camera around here, and we'll be right back. So here's the dry valve. This is quite an old dry valve. I think it's it was put in 1973. I've seen older ones than this, but this is I thought this would make a really good video, because we come out and service this annually, and sometimes we have trouble with it. But I just wanted to just kind of show you guys a little bit about these valves. They all work the same. They just are set up a little bit different, but they all generally work the same way. And I'm going to go into detail on how these things work. What we do is I'm just kind of explain. This here is your air pressure gauge, and the one you see back there is your water pressure gauge. If you guys can see in the very back there, you'll see another gauge up there. That's just your gauge that sits on top of the accelerator. Now, the accelerator is a device that's not always on dry systems, but it can be added, and all that does is it basically accelerates the time that dry valve is going to pop. So essentially, it's just a device that allows the dry system to relinquish all the air in the system much quicker, so that the clapper can open right away. So yeah, that's why they call them accelerators. Right here is your air maintenance device. You're going to see these on pretty much every dry valve. It's required. What you guys are not going to see on newer valves is this. It's what they call a fill cup, and you add water in here, and then you just open the valve, you pour water down, and it goes inside to this dry valve. So here's your faceplate. You have your main drain to drain the system down. Come down here, and you have your control valve, or otherwise known as an OS&Y. You always want to be careful when you pull any dry valve plate off. You always want to make sure that there's no air pressure or water pressure behind this plate before you take it off, because if you don't, you're going to have a big surprise. So first thing you want to do when you're shutting the system down and you're going to work on it, come over, shut your OS&Y, make sure it's shut completely tight. These valves, sometimes you got to put a wrench on them, the old ones, just to get them to close. If they do leak by, a fail safe to make sure nothing goes wrong or whatever. Still come over here. After you shut that, you're going to open up your main drain. What that does is it takes whatever pressure is on this valve between here and the clapper. It's going to take that pressure off. And then I always recommend you leave it wide open while you're working on it, so that if that valve is leaking by, it'll just go over and out the drain. Okay? Just a little tip there you guys need to know when you're working on a sprinkler system. So also just make sure that you can shut the air off here at the air maintenance device. A lot of times you'll see them have another control valve here, or a little valve here, which is the main airflow going in. You can always shut it right here. So, you know, before you shut everything down, you want to get your air shut off first, okay? And then also, if you do have an accelerator, you want to come back here, and whatever valves you see going to the accelerator, just shut them off. That way, you know, especially if you don't want to have to reset the whole accelerator. Usually what I'll do is I'll come in here and I'll shut these valves before I do anything, and make sure that it doesn't trip. If it trips, then you got to go through and reset that accelerator, which is something I'll have to do on another video. Okay, so now we got the system drained. I'm going to get my tools out and open up this plate. So I'll be right back. Okay, operating stem and yoke. So this one doesn't have a monitoring system, so some jurisdictions require you to take a chain and to lock off this control valve. That way nobody can come over here and shut these off. That's why you see chains sometimes on these old sprinkler systems, because they don't usually have the electrical tamper on this, so it's just been wired. Also, this system is not monitored. It just has what they call if you notice here, this line right here, this goes up and outside to what they call a water motor gong. And it's just you know, when the system trips, water will go up there and hit that gong, and it'll spin a little dial in there and cause it to ring, and that's how they would know if there's a fire in the building or if the system is tripped. So that's kind of basically everything here on that for now. What I'm gonna do is I'm gonna drain the system down air so that I can open up this faceplate and you guys can see what's inside. So let me get my tools ready and I'll open this up. I'm not gonna show you guys how I'm doing it, but I'm gonna open it up and then I'll be right back. When you're taking these face plates off, another safety feature you want to keep an eye on when you're taking these off is, you know, just make sure that when you take this plate off that you have at least 1 or 2 bolts in it before you break this seal on this, in case there is a lot of water or pressure behind this. It's just a, you know, safety hazard that you guys want to take when you're taking these off, because I've heard of stories of guys taking these off with pressure behind it and either getting really hurt. If you got 40 psi behind this and you go take this thing off and it blows off, it can kill you. I just heard bad stories about people messing with these and not taking the precautions of making sure you're being safe when you take them off. So just a little side note when you're taking this off. So let me get this face plate off and we'll go from there. So I got the face plate off. What I did is I just let the bolt in and kind of swung it up. That way I can work on it. So excuse my light, I just stuck my light in there so that I can kind of show you guys what's going on in here. So what you want to look, what you're looking at here is this ring right here is a sealing surface, as well as this inner ring right here is a sealing surface. What this seals off is the water coming up from here in that center hole. This ring here seals the air that's on the top side of this valve from going in. And so that's how these dry systems are set up and work. is your water comes up from there, and the air is on the top side of this, what you would call a clapper. If you look here, this is a piece of rubber. All these old valves, you see these rubbers on here, and they're actually removable. If you pull these bolts out, this is a metal plate here, and pull these bolts out, and you can take this rubber and replace the rubber on them. I don't know if you can get these, but you can take them. Well, in our situation here, we couldn't find these rubbers, so we just took it to a rubber manufacturer, and they made us rubbers from the old ones that we had, took them in, and they just kind of basically made the same rubber base, and so we were able to replace these. I can show you over here. This is the old one right here that we had, and it was just giving us a lot of trouble because there's, you know, grooves and stuff in here, and you can see where this plate sits that holds this rubber in. But we were having issues with this because the rubber, you see all these indentations over time. The rubber just doesn't want to seal anymore due to all these indentations, and then the corrosions you see here and what have you. So those things will cause problems and cause it to trip a lot. So we ended up replacing the rubber. So now what's important here too is to remember is that I said this side is the air side, and that inner circle part is where the water pressure is. And then you have what we call the intermediate chamber, and that's this chamber that goes around this water chamber, the water inlet. So, and you'll see that there's a little hole back there. What they call that is the intermediate chamber, and that has no pressure in it. So this inner side of the circle here is water pressure. This has no pressure, no water, no air. And then on the outside here, outside of this major ring is the air side. So there's 3 chambers. There's your air chamber, water chamber in the middle, and then right in between is your intermediate chamber. That little hole right there goes out into these pipes that are over here. Let me show you. We come over to actually, you'll probably see it better on this side here. Excuse me, it's kind of a tight squeeze in here. So where that hole leads to is it comes out to here and goes down, and there's a ball valve here, but that's not supposed to be there. It's actually supposed to be a spring-loaded ball check. I'll tell you why we put it on there later. But that goes all the way over. So when the system trips, like I said, in that intermediate chamber, there's no pressure in there. So if it trips, water is going to go inside to that intermediate chamber, and it's going to start running out of this. And that's a sure sign that your system is tripped, because there'll be running water through this thing. You're not supposed to have any air running through this or water running through this. If you have air running through this, then you have a leak on your clapper. Another sure sign that you're not sealing properly on your air side is if you're getting air out of this. It's just telling you that is your dry valve clapper rubber is not sealing on this edge properly. And it could be that there's debris on this rubber, or debris, or a little pebble, or corrosion might be just sitting on this and causing it just to barely leak by and let air in. So remember, intermediate chamber stays no pressure, and that little hole will tell you what's going on if you're getting water or air. If you're getting water in that means that this seal right here is not sealing properly either. So you might have debris on this. So that intermediate chamber can really help a service guy. But if you see air or water coming out of this, that's a sure sign that you're not sealing properly somewhere. When you're getting ready to set up the valve, you want to look and make sure nothing's coming out of it. It's just atmospheric air pressure, no air or water. So if whatever you had to service this rubber, you could take those bolts off. And if you look down here down below here on this, you just take that little plug out and there's a pin in there. And then if you go on the other side, there's another plug right there, and you can just push that pin out, and that'll release this clapper so that you can pull it out and replace the rubber or whatnot, or check it out, make sure everything's looking okay on it. So right now I'm gonna take my light out of here. And you can see that the clapper's, just sitting open. And that's because it's sitting on a lever up there that's holding it up. So when this thing trips, it hits up on that lever and it stays open. It keeps it open so that the water can keep flowing. It's not trying to fall back down while the water's trying to come in. And, if there's a fire, you want that thing to stay open so that you're getting the maximum water pressure coming in to the system to put the fire out. So when you're getting ready to come over here to reset the valve, like I said, go through, check around the rings, check your rubber on the clapper, and just make sure that just make sure that you're going to seal properly on the valve. Okay, so I'm gonna, excuse me for moving my camera around so much here. Let me come right back because I can only do this with two hands. So, okay guys, so now I got my face plate back on. Now on these old dry valves, it's not like the new ones. These old dry valves, they require water before you start putting air on it. So what I'm going to do here is I'm going to pour water in this, and this water is going to go in. I'm going to open this up here, and this water is going to go down in here, and it's going to follow this line, and it's going to go into the dry valve and come in right here. And what it's doing is you want to pour the water in there so that it comes up to like a level like here. And what that's doing is it's kind of helping it seal that clapper in there. So that's why they put these on there, is that just so that you can add what they call prime water in here to prime the valve. And you're setting water in here, and what happens when that air pressure comes in, it just pushes down on that water, and it creates basically like a seal on that valve, and it's kind of putting pressure down on the water to keep that clapper down. So that's what the water, why they have these fill cups. So if you ever come across an old one, you see this cup sitting up high next to the valve, which is usually the case, it's just a fill cup, and you have a valve here. So you want to open that up so you can allow the water to go in. So I'm going to fill that right now, and I'll be right back. Okay guys, now I got the system set up with air, just air only. and I'm getting ready to put the system back into service. So now my air pressure is all up. You know, if you look here, I got the air maintenance devices all set up. I shut the fast fill valve, and then I have the slow fill valves here um, set up open. So everything's ready to go with the air. Now I'm gonna go ahead and start putting a little bit of water in it. Now before you start putting water into the system, you want to make sure that your main drain is open. And when you're getting ready to start the water process, so I'm gonna come over here, open up my main control valve, and I'm just gonna crack it a little bit, so you start to hear the water moving. All right, you can hear the water moving a little bit. And now what it's doing is the water's just going up and straight out the drain. Now, after you start hearing the water, then you want to come over here and you want to start slowly closing the main drain valves. And while you're closing it, you're keeping an eye on the water gauge and watching it go up slowly. So when you're closing the main drain, you want to kind of go slow, because you don't want it to water hammer the clapper. Well, it's almost closed. Okay, now it's starting to build pressure, and I'm just taking it really slow. A lot of times on this old valves here, you gotta take some type of wrench and just give it a little bit of tight, or just the old valve, just to make sure that it's not leaking water all the time. So now I didn't hear it clunk. If you hear it clunk, it means your system just tripped, and you want to open up this drain as fast as possible. And that's why you always crack these a little bit. That way you're not filling the entire system really fast. So now that we know that everything's all set up and done and the water pressure's up, I'm going to come over here and I'm going to start opening my control valve. Okay, it's all open. And before you leave, you just want to make sure everything's all set, hunky-dory, looking good. And on this system here, it's a little unique. It's not monitored, so I don't have any tampers or any pressure switches on this. It just says a water motor gong. It's not monitored, so because the system is old, I know I showed you guys on here, it has an accelerator. Until the owner decides that he wants to revamp the system, we've kept the accelerator shut off, just because this system is so sensitive, and if it just feels a slight bit of pressure release, it'll trip. And I know that the system is always constantly tripping, and the owner's always having to come out a lot of time in the middle of the night because the bells ring. So that's why we ended up shutting off the accelerator, so that he's not having all those problems. It's something I don't recommend anybody do with their systems, but this is a old steel building, and it just has its old weaknesses, and there's just some things that you might end up having to do, but it's not a recommendation that you shut those accelerators off because they're designed to open quicker and get the water out faster to those sprinklers in case there is a fire. So, but in this situation, we have it shut off just for the reason of it being so old. And then, like I said, when the owner has enough of the funds to replace this entire thing, then we'll consider putting back the accelerator and everything else. So, but that's it, guys. I hope you learned a little bit about how these dry systems, things that I would want you guys to watch out for when you're looking at these dry systems is all this trim that you see on here, specifically the air trim, the air lines. But all this trim that you see on here, if you notice, it's black pipe. Highly recommend if you ever see black pipe and black fittings on trim. It's not a good thing. Having black fittings, black pipe on an air system like a dry system is not good, because what happens is you have the air and the water. When this has moisture in it, it'll start to corrode, and it'll corrode really quickly inside these fittings. That's why if you notice on these newer dry systems, you see all the trims done at galvanized, and that's because you don't want these fittings to start get corroding, especially the airline. If this airline gets corroded here, and it's black fittings inside here or whatever, it'll jam up and clog those airlines up, and then you'll wonder why, your air compressor's good. Why did it trip? And a lot of it is because the corrosion inside those black pipe and black nibbles will start to build up over time and basically seal the pipe off, and now you're not getting any air to your dry valve, and you're supposed to get a little bit of air through this air maintenance device. That's why it's got a restricted. And all this does really is to allow a little bit of air at a time if there's small little leaks in the system. But if you have anti-corrosion in here because of black pipe or black fittings, and you're doing troubleshooting these things, check your air lines, make sure you're not clogged up. You might have to go through and take apart all the fittings if you see black pipe. Good guarantee that it's corroded. Too, if you see any check valves in here with the screens on them, some of these other check valves with the Y check valves with the screen on them, check those. Those get clogged up too, so you want to open them up and clean them out. Those are things you want to think about. So other than that, I think that's pretty much it. The best thing about when you guys are doing any type of service work and you're troubleshooting these dry systems, I highly recommend that you guys know what they do. It's so important to understand how these things really work and know what lines are air lines and what lines are water lines, and then what lines don't have any air or water in it. And once you understand what all those components do in a dry system, it's going to make your troubleshooting job, so much more easier. The other thing I recommend too is having a spray bottle with soap in it, like some kind of cleaner. This can help too. You can spray all your joints that has air in it. Sometimes you can spray these face plates, make sure they're not leaking, or they're leaking out of these bolts right here. I've seen that happen. You spray the couplings on the pipe, just wherever you think it could possibly leak air. That's why having a bottle of cleaner is very handy when you're troubleshooting these. Outside of that, that's pretty much it with these dry systems. These old dry systems, they can be really cumbersome, and sometimes guys will just give up on them because they don't understand why it's not setting up properly, and they pull their hair out and what have you. Just take time to understand what you're looking at and what you're doing and how these things work. They all pretty much look different brands, but they all work the same. And then I wanted to quickly expose a myth out there on these. There's a myth that goes around in our industry about air versus water pressure. Well, guys think that air pressure is greater than water pressure on these dry systems, and that's not the case. That's a myth. So don't ever believe when somebody tells you that 40 pounds of air pressure is equivalent to 100 pounds of water or whatever it is. Don't believe that stuff. It's not true. That's why they call these differential valves. And the reason they call them differential valves is, as I showed you earlier in the video, if you notice on the top side of the clapper, you have this much of surface area, okay? And that much of surface area of water, the air is pushing down on that large surface area. And then you noticed in the video that the water coming in to the dry valve is only about this big. So the clapper on that side that's holding that water down is only this big. If the surface area is only about that big compared to the air side is this big. And so they call it a differential valve because there's a difference between the top surface area and the bottom surface area. The top surface area is 5 times larger than the water side surface area. So what that means is that if you have 5 times the pressure up on top and you have 5 to 1, then, so if you'd say you got 25 psi, or let's say 20, and let's make it easy, 20 psi coming in water pressure, all it's going to take is you take 5 and you divide that by 20, and that comes out to 4. So all you would need is 4 psi to hold back that 20 psi. That's where that 5 to 1 ratio comes in. Sometimes it's 4 to 1 ratio. On these old dry valves, they're a little different with the new dry valve systems. They're a little bit more advanced, but on these old systems, they're usually 5 to 1. So like if you have 100 psi of water coming in under this, which this does, you want to take the 5 and divide that by 100, and that comes out to 20 psi basically. So all it takes is 20 psi to hold back that clapper. Now I pumped it up a little bit above the 20 psi because the rubbers in this thing are getting old, so I had a little bit more pressure to help hold back that thing, because it's a little old, but 20 psi is what's going to hold back that. So then you want to add to that a little bit, so for a safety factor, because you don't want it to trip like right away, so it loses a little bit of air pressure. So always the safety factor is, I think, 10 psi or tripping point. So yeah, don't ever believe that myth that air is greater than water. It's not. So these things are differential valves. That's why they call them that, because the ratio is different. So hopefully that teaches you guys something new, and I hope this was interesting. I'm going to come back and do another video real quick, and this one's going to be on air maintenance devices. So appreciate you guys' time. Comment if you have any questions about what I did here, and if you like this type of content, I'll do more. I'm trying to get another dry valve from a friend, an old one, and I'm hoping to try to take one apart, cut it in half, and that way I can kind of show you a little better what the insides look like. But understanding these systems in and out is going to help you with troubleshooting. So hope you guys liked the video. Please comment, subscribe, and I appreciate you guys watching the videos. Thanks.